this one is the same. Should be equal to the force over the area. And you can got okay. So that's number 6. And then number 7, a block of metal weighs 40 Newton in air and 30 Newton in water. What is, how to pronounce this? Buoyant?
The buoyant force.
Buoyance.
Yeah.
Because this is from the water, right?
Mm-hmm.
So if it's weight 40 Newton in the air and 30 in the water, that means the force from the water should be 40 minus 30, right? 10 Newton. It's very straightforward. It's A. And number 8, a crane lifts a steel submarine. So the density of this submarine is 7.8 times 10 to the 3 kilogram per cubic meter. And the mass is 20,000 kilograms. So first thing we need to calculate the volume, right? It should be the mass over the density, okay? If you calculate, you got plug in the number 20,000 times 0.8 times 10 to the 3, 2.564 cubic meter. So that's the volume of the submarine. So what is the tension in the lifting cable? So there is a lifting cable. When it's number 2 is very easy to answer. When it's entirely out of the water, so there's only gravity. So you only need to calculate gravity times 9.8. So it's around 2 times 10 to the 5th Newton. And number 1 is when it's submerged in the water. And there is a force from the water, which should be the water times the volume times G. Okay? That's the force from the water. And if you plug in the number, you got 25,000 Newton. And you just need to subtract from the total gravity from the force of the water. If it's in water, there is tension, and then there is a force from the water, right? So the tension will be less. Just need to use mg, divide this, and then you will get around 1.7 to the 5th Newton. Okay, so that's this question. Then number 9, a piece of aluminum with a mass of 1 kilogram and density of 20,700 kilograms per cubic meter. So the mass is 1 kilogram, it's number 9, and the density is 27 kilogram and then completely immersing it. So you put it in the water. Put it in the water. So number A, determine the volume. The volume is where it is mass over the density. That will be the volume. If you calculate it, got 0.37 cubic meters. Okay? Just plug in these two numbers. And B is determine the tension in the stream after the matter is immersed in the container of water. Determine the tension. So we have tension, gravity, and then force from the water. Right? So the tension should be gravity minus force from the water, which the gravity is 1 kilogram times 9.8. Force from the water will be density times volume times gravity. Okay? And then if you calculate it, it's 9.8, plug in the numbers, you got 3.6296, and then if you calculate 6.17 Newton, that is the tension you have. Okay? Clear with me? It's number 9. And number 10 is 1 cubic meter object flow in water. So that's water. So there's an object floating in the water. 20% outside of the water, 80% inside of the water. What does the object weigh out of the water? We know in total is 1 cubic meter. So inside the water is 1 cubic meter times 80%. That's what is inside the water. And then if we calculate how much weight is this water, we can get the weight. It should be equal to this object. The water density of the water times G. That's the volume of the water, right? So if you calculate it, it's 80% times 1,000 times 9.8, which is equal to 7840 Newton. So it's D. Okay. And number 11 is quite similar to this one. It tells you a solid object floating in water with that is water. This object is floating there, and 3/4 beneath the water, the surface. What is the object's density? So the density of the object times the volume of the object is the mass, right? Times G, of course, is the weight of this object. It should be the weight of the water here, right? The weight of the water, the density of the water, the volume should be the volume here times 3/4. There's only 3/4 inside the wall. Times G. Okay, so we cancel these, cancel these. So